Hi class, this is Mrs. Cornett, and I am going to work through some problems that are found in section 6.5. This is solving quadratic equations by factoring. So in algebra, there is a property called the zero factor property, and it's something that we all know of. We all just accept it to be true. It says if you're multiplying A times B, and if that product equals 0, this is what the property says. Then A equals 0 and or B equals 0, right? Don't we know that? If two numbers being multiplied together equals 0, one or both of those numbers have to be 0. And so we're going to use that property to solve the problems that I have for you in this video. In each of these problems, we are going to be looking for two values that the variable could be to make these equations true. So take a look at the first one. We have the number x times the number x minus 5, and that equals 0. And so we're going to take each separate part of this multiplication problem and set that part equal to 0. So for example, the first number was x, so we'll say simply x equals 0. If x was 0 and we plugged it in, it doesn't matter what x minus 5 is, because then you would multiply by 0 and the whole equation would have a value of 0. There's another number, because what if x minus 5 equaled 0? What would x be? We can simply solve this equation and x equals 5. So let me explain why. If x was 5 and you plugged it back into this original equation, 5 minus 5 is 0. And even if you had a 5 here on the outside, 0 times 5, it's still 0. And so you're going to have two answers. WebAssign will ask you to put a comma separating your answers. So in any order, you would write x equals 0, comma 5. Okay, let me try that again. We have the number z times the number z minus 3, and that multiplication problem equals 0. There's two possible values for z that could make this statement true. The first one is z could simply equal 0. If z equals 0, this would be 0 times a negative 3 if I substituted 0 in there, which does equal 0. But I could also take the second number, which was z minus 3, and say that part, that one could equal 0. Well, if the z minus 3 number equaled 0, what would z have to be? We can add 3 to both sides, and z would equal 3. Because if we plug 3 back into that original equation, it would be 3 times 3 minus 3, which is really just 3 times 0, which is 0. So your two answers are 0 and positive 3. Okay, take a look at number 3. You have the number y minus 2 times the number y minus 3, and when you multiply those two together, it equals 0. So here's your two options. Either the y minus 2 value equals 0, or the y minus 3 value can equal 0. What would y have to be to make these simple equations true? We can add 2 to both sides. If y was positive 2, and we plug that into the original equation, it would equal 0. Or if y was positive 3, and we put that value into the original equation, it would also produce of 0. And so your two answers are 2, 3. Okay, let's skip down to number 5. This is 2t minus 5 is your first number times the number 3t plus 1, and all of that. And when you multiply those two together, it equals 0. So here's the two options. This 2t minus 5 could have a value of 0, or the 3t plus 1 could have a value of 0. I'm just taking each of those and putting equals 0 on the end of them, and then solving for the variable. If the 2t minus 5 value equaled 0, let's figure out what t would have to be. In order to do that, we're just going to solve for t, add 5 to both sides. That's 2t equals 5. Divide both sides by 2. T would have to be 5/2 for that entire expression to equal 0. Over on the right side, for the 3t plus 1 expression to equal 0, we have to solve for t again. This will be 3t equals negative 1, divide both sides by 3, and t would equal negative 1/3. So your two answers are positive 5/2 and negative 1/3. Let me show you some harder examples of the zero property factor. The reason I call them harder is because you have to first factor these expressions first and then set each factor equal to 0. So it's not really harder, it just adds an additional step. So take a look at 7. X squared minus 16 equals 0. Now you should recognize this from last section. This is a difference of squares. It factors to x minus 4 times x plus 4, and that still equals 0. Now we can say if the x minus 4 value equals 0 or the x plus 4 equals 0. Do you see what our answers will be? We will have a positive 4 and a negative 4. And those are your two answers. Take a look at 9. 3y squared minus 27 equals 0. The first thing I notice is that they both have a common term of 3. So I'm going to factor that out first and see what it looks like. When I factor 3 out, I'm left with y squared minus 9 equals 0. But do you see that I can factor one more time? This is a difference of squares, y squared minus 9. So I'm going to put the 3 out front, and this is y minus 3 and y plus 3. All of that still equals 0. All I did was just rewrite the original expression. And so focusing on this bottom line, we can actually ignore the 3 and we can just focus in on the y minus 3 part and the y plus 3 part. Because if y minus 3 equals 0, the whole expression would equal 0. The value that will make this true is y equals positive 3. And then we'll set y plus 3 equal to 0, solve for y to get a negative 3. And so your two answers are positive 3 and negative 3. And your answers just mean if you were to plug either one of those values in for the y variable, the entire expression would equal 0. Take a look at number 12. It's x squared minus 8x minus 9 equals 0. Before we can solve for x, you need to factor this trinomial first. We're going to draw two parentheses and put the x in the first spot of each parenthesis. And remember how this works. We're looking for two numbers that add to negative 8 and multiply to negative 9. And that would be negative 9 and positive 1 equals 0. If the x minus 9 value equaled 0, do you see that x would have to equal positive 9? If we add 9 to both sides. If x plus 1 equals 0, we'd subtract 1 from both sides and x would equal negative 1. So in this original equation, if you let x equal 9 or negative 1, either one of those, when you plug it in, the expression will have a value of 0. Okay, before this video gets too long, let me just show you some of these off of this page, because you're going to have to do one extra step and then factor and then set it equal to 0. And that extra step is, do you see how none of these in their original format are set equal to 0? So for each one of these problems, the first thing you have to do is move everything over to the left side. So take a look at 16. X squared minus 2x plus 25 equals 8x. First thing, before I can even factor, I have to subtract 8x from both sides. And I'm going to combine like terms. I had the negative 2x and the negative 8x, which is negative 10x. Then just bring down the positive 25, bring down the x squared, and then 8x minus 8x over here on the right side equals 0. That was the extra step that all of these problems on this page you'll have to do. Now we are ready to factor. So let's rewrite this trinomial as x minus 5 times x minus 5 equals 0. And do you see, because the terms are the same, our answers are going to be the same. All this means is that there's only one number out there that will make this entire expression equal 0, and that's going to be positive 5. Because when we add 5 to both sides, And so you can just write one answer in WebAssign. You do not have to write 5, comma 5. Actually, they may mark you wrong. Just write x equals 5. Take a look at 21. It's 2y squared minus y equals 3. First thing is to subtract 3 from both sides. There is not a common number for that minus 3 to join up with, so just tack it on the end of that expression. That will make it a trinomial. And then of course 3 minus 3 is 0. And now we're going to go ahead and factor this. I'm going to quickly go through this slide and divide method, which you can find more videos. I'm going to work this out through the slide and divide method, which in class I also call this Swedish fish method. You can check out videos from section 6.3 if you need extra help. So this will be y squared minus y minus 6, and then that factors to y minus 3, y plus 2. Now go back and divide by your a term and simplify and then swing the denominator. So this will be a factor of 2y minus 3 and a factor of y plus 1. Okay, we did all of that just to get to the factored form. Now we have to solve the problem. The zero factor property says either 2y minus 3 equals 0 or y plus 1 equals 0. And so now solve for y to determine the value that y would have to be for this statement to be true. Over to the left, we'll add 3 to both sides. 2y equals 3. Divide by 2, and y equals a positive 3 halves. Over here, y plus 1 equals 0. We'll subtract 1 from both sides, and y equals negative 1. So your two answers that will make this entire expression have a value of 0 is 3 halves and negative 1. Okay, let me show you one more on this page. This is number 19. T squared plus 6t equals 16. Subtract 16 over, and that makes the trinomial t squared plus 6t minus 16 equals 0. We can factor this to x plus 8 times x minus 2 equals 0. And there's our two factors, so either x plus 8 has a value of 0 or x minus 2 has a value of 0. And we'll quickly, for both of these, just solve for x. We'll subtract 8 over here, so x is negative 8, and then we'll add 2, and x is 2. And so what those two numbers mean, negative 8 and 2, if you were to substitute either one of these into the t squared plus 6t minus 16 equals 0, that would be a true statement. Well, that's all I'm going to do for this video. Please let me know if you have any questions.